Hello, everyone. I'm Carmen, and I'm a PhD student at UCL. I'm part of the Nanoengineering Systems Lab with Professor Manish Tiwari as my supervisor. In our lab, we develop and apply nanoengineered technology to different healthcare applications, one of them being operative birth. So nanoengineering essentially means engineering on a tiny scale, so on the nanoscale. Through the WISE Center of UCL, we have been working in collaboration with a number of obstetricians from UCLH, Shireen Jaffarali, Dimitris Sasakos, and Anna David. And together with Professor Desjardins and the rest of the team, we have focused on developing a medical device which will be able to improve the safety of operative birth. The device that we have developed is a sensorized surgical glove, as you can see on the figure on the left-hand side, which has specialized sensors on the fingertips, which are able to tell the orientation of a baby's head during the vaginal examination during labor. So essentially, during labor, the way obstetricians tell the orientation position of the baby's head is by carrying out a blind examination in which they try and see if they're encountering either the anterior fontanelle, which you can see in red in the figure on the right, or the posterior fontanelle, which you can see in green in the same figure. The thing is, with these examinations, they're highly subjective and they vary from obstetrician to obstetrician, and they're up to 50% and over inaccuracies when trying to tell the position the baby's head is in. So the way we want to tackle this and help improve this process is by means of our sensors, which are on the fingertip of the gloves. These sensors are actually able to tell whenever you're encountering a suture. The sutures are what you can see in orange on the right-hand side. So it's basically where the skull bones meet. And they have different sort of material properties to the skull bones. So for example, in rigidity. And that's something that the sensors can detect. So the sensors can faithfully and objectively and thus quantify this process by detecting the sutures and basically counting whether we are encountering either 4 sutures, and then we would be in the case of the anterior fontanelle, shown in red, or if we're encountering 3 sutures, we would be in the case of the posterior fontanelle, which is shown in green. In this way, we aim to improve the safety of operative birth. So from previous PPI sessions, which we have carried out, we've obtained great feedback and really positive feedback, especially if this surgical glove will be able to reduce the number of examinations that people have to go through during labor. Also, actually, we have obtained really good ideas as well from brainstorming with the PPI panel. So for example, one person mentioned that it would be good to also have force readings on the sensors. So this is actually something that we have now incorporated as well. So not only do they detect the position of the baby's head, but also the force exerted by the obstetrician on the baby's head in real time and at all times, in order to make sure that not too much force is being exerted, so to further improve the safety. And in the future, we aim to test the surgical glove on a number of laboring people in order to check that it works and that it's comfortable to use. And we would love to continue gaining feedback from the PPI panel in this process of continuous improvement, not only in terms of the design and development of the sensorized surgical glove, but also in terms of the design of the test that we will be carrying out in laboring people. So for example, in terms of designing the leaflets and the consent forms. Thank you so much, and I can't wait to start working together.